Today we're going to be taking a look at two different expressions and how to factor them. The first expression is called a perfect square trinomial, and it looks something like this. And when you use algebra tiles, it looks something like that. And the other expression we're going to be looking at is a difference of two squares, sometimes called a difference of perfect squares, and it looks something like this, and that is how you use algebra tiles for it. We're going to be taking a look at each one at a time, and hopefully it will make sense once we're done with them. If you need to work along with us to find this page, I am on my courses, chapter 16, exploring, and then go to factoring. And then I am on page 9. I'm on page 9 in Agile Mind. We're going to start with the perfect square trinomial. Now, notice that first it is a trinomial, which means that there are three terms separated by pluses or minuses. That's a trinomial. So it has to be three terms, otherwise it's not a trinomial. So that's the first thing. It's a trinomial. Okay. The next thing is, notice how it's set up. Let's talk about what's in this box. We have x squared, right? Then we have the plus 9. The plus 9 is right here. There's 9 pieces right there. And then 6x. Here's 3x. And here's another 3x. And altogether, that's 6x. So there are our pieces. Now, notice that the shape that they make is not just a rectangle, because remember, it's enough to factor by making a rectangle. It's not just a rectangle, it's a square, okay? And because we are making a square, this whole thing is a square. And because we are making a square, we call this a perfect square trinomial. Now let's look at the individual pieces of it. The square part is the x squared. That in itself is a square, right? So that's a square. And this square right here with the 9 pieces is also a square, right? And then the rest of it that fills in, you see how there's the same stuff inside. So we have 3x here and we have 3x there, and that completes it, and that makes the whole thing a square. But the individual pieces, x squared and the 9, those are also squares. So that's an important thing to notice. So let's look at a few examples of what perfect squares are. So the first perfect square that comes to my mind is x squared. That in itself is just a square. Now, let's say I took a square and I broke it up into pieces. And let's say they were all x squared. X squared is a square, x squared is a square, x squared is a square, x squared is a square. So notice another type of perfect square is 4x squared, because there are 4x squares in there. All right, let's take another look at a perfect square. If I was to keep going with x squareds, I can break this up into 9 pieces, and I can put an x squared into each box, right? So another type of perfect square with x squareds in it is 9x squared. And we can keep going. Another perfect square would be 16x squared, right? You can break a square up into 16 pieces. or 25x squared, that's a perfect square, and so on. All right, let's talk about perfect squares that are numbers. So one type of perfect square is the number 1 because a 1 by 1 square has an area of 1. So 1 is a perfect square. What's the next perfect square? If I had a 2 by 2, another perfect square is 4. So 1 is a perfect square, 4 is a perfect square. What's the next perfect square? Well, if we had a 3 by 3, 9 is a perfect square. Notice how these are matching up to our x squareds. We had 1x squared, 4x squared, 9x squared, and so on. So we can also have a perfect square of 16. What's another perfect square? Let's think big. I'm going to make a square, right? And let's say I'm just going to randomly choose some numbers. How about eights? So if I had an 8 by 8, what would be inside the square? Well, another perfect square is 64, right? Let's do one more. So if I had a 9 by 9, for example, a perfect square would be 81, and so on. And there's an infinite amount of perfect squares, but it's important to understand what they are. Let's do a few examples of a perfect square trinomial. So we're just going to make one up. Now, we already talked about how to make perfect squares with x squared. So for example, 1x squared is a perfect square. 4x squared. What's the next one? 1, 4, this is 1 times 1, this is 2 times 2. 3 times 3, 9x squared. 4 times 4, 16x squared, right? And so on. And for regular numbers, we would just write 1, 4, 9, 16. Let's keep going, 25, 36, and so on. So what I'm going to do is I'm going to fill this in partially. Let's just start with x squared first. So I'm going to write x squared right here. So here's our perfect square. And then I'm going to write, let's say, 9. Okay, so I'm going to put a 9 over here. Now, how would I fill in the rest of the boxes? So if there are 9 cubes right here, right? How would I fill in everything else? Well, notice I would just extend this way, right? And I would extend it this way. So what I have inside is right over here. These are x's, right? So what I have is 3x, and I have the same thing over here. I have 3x. Now remember, the 3x's add together and they make a 6x. And then the rest of it is x squared plus 6x plus 9, right? And we have just made up our own perfect square trinomial. So once again, this is a perfect square, and this is a perfect square. And notice that 3 times 3 makes 9, but also 3 plus 3 makes 6. So keep that in mind as we do more examples. So let's say we had a perfect square trinomial, but we weren't sure what went in the middle of it. So far we have 4x squared and 9. So let's just break that apart a little bit. Now 4x squared is actually 4 squares of x squared, right? And 9 is actually 9 squares of 1, right? There's 9 ones in there. So what would we do to figure out the number in the middle? Well, we do exactly the same thing as we did before. we extend the line. But this one is a little bit different because notice over here there is a line on the x squareds. So we also have to extend the line in here. So then again, I'm going to extend the lines right here, and then I'm going to extend the line right there. Now, again, those pieces that are in there, these are all x's. So how many x's are there? Well, if you count them up, you'll see that there's 6x in this box, and there's another 6x in that box. And altogether, that number in the middle is 12x. So here we have a piece missing, and again, we are going to make a perfect square trinomial. But notice this time we have a negative in the middle. So we're looking for a negative sum. So let's see if we can find it. Now, in the beginning, we have a 9x squared. So I'm going to break that 9x squared into pieces. So 9x squared, we can break up into 9 pieces. I'm going to make a square here. And these are all x squareds. Remember, there's an x squared in each one. So I'm going to stop here. I know we've done this a bunch of times, so you guys should understand that by now. We have 9x squareds in there. Now, the 1, that's just 1. So we're going to leave that as just that 1 square. There's nothing to break up. Now, let's break the rest of it up. So again, we're going to stretch this out this way. And the other way, there's nothing to stretch out because we didn't do anything here. So again, we're going to break it up this way, but there's nothing to break up the other way. Now remember, these are all x's. And how many x's do we have? Well, if you add them all up together, you'll notice that we have 6 x's. But remember, they are negative, right? They are negative. So that is a negative 6x. All right, let's do a few examples of how to factor a perfect square trinomial. So here I have an x squared, and I'm going to put the x squared in this box, and then the 16, and the 16 goes in this box. Now remember that this 16 needs to be broken up into pieces. So let's break that up. Now, a square that is an area of 16 is a 4 by 4 square. So notice these are all ones, right? These are all ones. I'm not going to do all of them, but as you can see, it's a 4 by 4 square. Now we're going to extend the rest of it just like we did before. I'm going to go this way. And there is nothing to do here with the x squared because the x squared is just 1 square, so we're not going to do anything with that. And we're going to extend this way. Okay, now these are all x's, and these are all x's. And notice that all together we have 8x. So we do have a sum of 8. So we did create the correct square. Now, how do we factor this? Well, we have to see what this is and then what this is. Since this is an area of x squared, this is an x by x square. Then, what is this length right here? Well, this is an x by 1 square. So these are all ones here, and we have a total of 4. Now up here, we also have ones for a total of 4. So that gives us x plus 4 times x plus 4. And notice that both of these binomials are exactly the same. And because they are exactly the same, we can just say that it's x plus 4 squared. And that's how you can express it as an exponent. All right, so here we have another example, x squared minus 10x plus 25. So I'm going to put the x squared here. I'm going to put the 25 here. Now, notice that we have a negative this time. So our x's are going to be negative. All right. Now, make sure that you break up the 25. Now, 25 is a 5 by 5 square. So I'm going to make it a 5 by 5. All right. Now, when you extend it, keep in mind that you have negative x's. All right. I'm not doing that great of a job here of extending. All right, let me do that again. All right. So I fixed the extending part. Now remember right here, these are all ones. And because they are negative, right, these are actually negative ones. And remember that inside the area is negative x, right? And the same thing in here. These are all negative x's. So we have negative 1 here 5 times as well. All right. Now, over here we have an x by x square. So let's see what we have. We have x and then minus 5 here because this is a minus 5. And then the same thing here, that's a minus 5. So this factors into x minus 5 times x minus 5. And notice that the two binomials are exactly the same. So again, we can write them factored this way, x minus 5 to the power of 2. Make sure that you have those parentheses there. All right, so we're going to do this without making the squares. If you want to try making the squares on your own, that's fine. Okay, so I have x squared. I'm going to put that here, and I have plus 100. So I'm going to put that there. And the negative 20x has to be broken up into two pieces. So I have negative 10x and negative 10x in my boxes. All right. Now keep in mind that that is a negative. Okay. All right. So over here, greatest common factor for x squared and negative 10x is x. And greatest common factor this way, it's the same thing. So that's x. Greatest common factor over here. Now, because you have a minus right there, it's going to be negative. And then what's the greatest common factor of 10 and 100? That's 10. So we have negative 10 here. And because over here, the column is exactly the same as this row, and this column are exactly the same, we're going to have the same thing, x minus 10. So to factor this, we have x minus 10 times x minus 10, and you can also write it as x minus 10 squared.
What is a perfect square trinomial? A perfect square trinomial can be written as a binomial. Remember, a binomial has two terms. A binomial squared. Okay, and an example of a perfect square trinomial, I know they have an example over there, but I'm going to give you a different example. Another example is x squared plus 18x plus 81. Okay, let's look at x squared plus 18x plus 81. Isn't 81 a perfect square? Yes, indeed. 81 is a perfect square. It's 9 times 9. If I double 9, don't I get 18? So this can be written as a binomial x plus 9, right? 9 because it's the square root of 81. And this middle term is 18. It's doubled. So it's x plus 9 squared.
All right, so we're going to switch gears here and we're going to move on to factoring the difference of perfect squares. So What I want you to notice here is that x squared is a perfect square and 25 is a perfect square. And the minus sign is called a difference. So this is a difference of perfect squares. In other words, there are two perfect squares and there is a minus sign between them. That is what a difference of perfect squares is. Once again, it is two perfect squares with a minus sign in between them. Or you could say it's a subtraction of two perfect squares. All right, so I'm going to fill in my boxes. I have x squared over here, and I have negative 25 over here. Now be careful, remember that that is a negative. Now when we break up our pieces, I'm just going to do this once with the pieces. So I'm going to break this up into a 5 by 5, because it's a negative 25. And remember, each piece is actually a negative one. Okay, there's a negative one each inside because that is negative 25. So those would be the red pieces. Okay, now let's extend these. So I would have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and then extend it this way. Now here's what you need to remember. There is nothing between these two numbers. That middle term with the x on it is actually a 0x. There is nothing there in the middle. So what we need to fill in here is a set of positive x's and a set of negative x's. Do you guys remember the term 0 pairs? And remember, 0 pairs are 1x, and then the other one, negative x. And remember that they cancel each other out. Okay, they cancel each other out and they give you a 0. Those are 0 pairs. So that's what we need to fill in up top. So I'm going to fill in 5 positive x's, and then I'm going to fill in 5 negative x's. And notice those are 0 pairs, and those are going to cancel each other out. All right, so what do I have here? Over here, I have an x by x square. And right over here, these are all lengths of 1, because this is length of x going down that way. So all together here, we have a plus 5. Now, if I go over here, be careful, these are all a length of negative 1, because this over here is x. So x by negative 1 is negative x. So these are all negative 1s. So this is negative 5. So if I wanted to factor this, I would write x minus 5 times x plus 5. Okay, this is my x plus 5, and this is my x minus 5. Now, what if I wanted to just do this without the box and just do this quickly in my head? Notice first thing you have to check is, do you have perfect squares, right? Is x squared a perfect square? Is 25 a perfect square? Yes, they are. The next thing you need to check for is, do you have a difference? If you have a difference and you have the perfect squares, then you can do this. So let's factor it without the box. All right. What is the square root of x squared? In other words, what times what is x squared? So we're going to break that up into x times x, right? We're going to do the same thing with 25. What number times itself is 25? Well, that is 5 and 5, right? Now, remember, there is nothing in the middle. We have a 0x in the middle. So we need these 5s when we add them to knock each other out. And because we need them to knock each other out, we're going to put different signs here. So it's x plus 5, x minus 5. All right, so here's a couple more examples of the difference of perfect squares. We already know x squared is a perfect square, so both of these have x squared. Notice 81 is a perfect square because 9 times 9 is 81. And notice 121 is also a perfect square because 11 times 11 is 121. So let's factor these now. All right, and I'm going to do this without the box because these are big numbers and it might be a little difficult, but you can still try it on your own. So again, we put an X here and an X there, and I'm just going to do this one at the same time to show you how easy this is. So I'm going to put X here and X here. Now, again, the middle term is missing, and because the middle term is missing, we know it has to be 0. So we're going to have a plus and a minus because the two middle terms have to knock each other out. So I'm just going to put a plus and a minus in both of them. You're always going to have that when you're doing a difference of perfect squares because that middle term is missing. All right, and since 9 and 9 makes 81, I'm just going to put 9 here and 9 there. And since 11 times 11 makes 121, I'm going to put 11 here and 11 there. And that's it. That's how you factor a difference of perfect squares.
Why is the polynomial called the difference of two squares? So it's called the difference of two squares because, I'll say because the two terms are both perfect squares and there is a subtraction sign in the middle. That's important. There's a subtraction sign in the middle. Okay, describe how to factor a difference of two squares. All right, so if I want to describe how to factor, first of all, let me give you an example. I'm going to pick the example. Let's say x squared minus 25. Okay, first of all, is this a difference squared? Is x squared a perfect square? Yes, x times x. Is 25 a perfect square? Yes, 5 times 5. Is there a subtraction sign in the middle? Yes. Okay, so when I factor these, I have to factor them as the two perfect, or the two square roots. X squared's root is x and x. 25, it has a root of 5 and 5. But what's different here is that you have to have a plus and a minus in the middle. Your two factors are going to be one is the sum and one is the difference. All right, so let's factor each polynomial. I'm going to go back to my box method. I think that's a great method to use. And I'm just going to show you here what this should be. Now, first of all, you can see that this is x squared minus 36. X squared minus 36 should be a difference of two squares because x squared is a perfect square, 36 is a perfect square, right? So right away, if I think about factoring this easily, what is the root of x squared? Well, I've got x and x. What is the root of 36? What times itself is 36? Positive 6 and positive 6. But I have a minus sign in there. Or it is a difference of squares. So in order to have a difference of squares, I need to have one of these as a minus and one of these as a plus. If you notice up here, I put a plus and a minus, and this is a minus and a plus. It doesn't matter the order that you put it in. Last question here. Last question here. I'm going to look to see if this is indeed a perfect square trinomial, right? My perfect square trinomial has a perfect square in the beginning and a perfect square in the end. My root of x squared is x. My root of 36 is 6. So if I multiply those two, I'm going to get 6x. Is 12x double 6x? Oh, actually, look at that. It says negative 12x. Well, what two numbers are going to multiply to be positive 36, but add up to be negative 6? Well, it turns out that I can have negatives in here. So let me see, I'm going to do this. I'm going to say my root for x squared is x times x. X times x is x squared. 36 is going to give me a 6 and a 6. But I need to have a negative 12x in the middle. How will I get a negative 12x? Well, I will only get a negative 12x if both of those are negative, because negative 6 times negative 6 is positive 36. And then negative 6 plus negative 6 gives me negative 12. So really the way I write this answer is x minus 6 squared. There's my answer, but again, I'm going to go and do the box method really. Okay, so I'm going to just show you the box method again, just to show you can always use this box method. Let me put in my numbers that I know. I know that this is going to be x squared, and I know this is going to be positive 36. And I know that my two numbers need to multiply to be 36x squared, but they need to add up to be my middle term, which is negative 12x. Okay, great. So now let me think of some factors of 36, things that multiply to be 36. Well, we just did that up there. 1 times 36, 2 times 18. Neither one of those are going to give us negative 12. 3 and 12. 3 times 12 is 36. That's not going to give it to me. How about 4 and 9? 4 and 9 is not going to give me negative 12. How about 6 and, oh, here we go, 6 and 6 again. Okay, but in order for me to get, and this is, you guys hear me talk in class about tightening it up. I tighten it up right now. 6 and 6 will give me 12, but it's not going to give me negative 12. So if I say the two numbers are negative 6x and negative 6x, negative 6 times negative 6x, negative 6x times negative 6x gives me positive 36x squared, and negative 6x and negative 6x gives me negative 12x. So great, my numbers are negative 6x and negative 6x. And good, let's do our factorization real quick. X squared minus 6x gives me a factor of x. Negative 6x and 36, this is a negative leading, so I'm going to have negative 6. 6x squared and negative 6x again is going to give me x, and negative 6x and positive 36, negative is leading, so I'm going to have negative 6 right here. So that means my two factors are indeed x minus 6 times x minus 6, or x minus 6 quantity squared. Have a great day, everybody.